In the last couple of lectures, we've been talking about random variables. Some examples of random variables were taking a random bag of M&Ms and counting the number of green M&Ms. Or in the case of binomial random variables, doing some random process a fixed number of times, such as picking 20 random people, and then counting the number of successes. For example, counting the number of people who play a certain game, for example, Wordle. Notice that in both of those situations, the number you end up with is a nice whole number. Those are examples of discrete random variables. Today we're going to talk about random variables where you don't end up with nice whole numbers, where you end up with decimals. So for example, if I take 20 random people and find their average age or their average height, you're going to end up with decimals. These are called continuous random variables. When we talked about the discrete random variables, a probability distribution was represented with tables like this one, where we listed out all the possible values of x along with their probabilities. Now for a continuous random variable, because the possible values can be any decimal, it's impossible to list out all the decimals. There's just too many. So instead of representing probability distributions with tables, for continuous random variables, the probability distributions are going to be represented with curves. That's a curve. This curve is called a probability density curve. On the x-axis, that represents all the possible values of x. So instead of listing out individual possible values of x, the possible values of x are now represented with a number line. And how do we represent probabilities? Probabilities are going to be represented by the area under the curve. So for example, if I wanted to know the probability of getting an x that's between 5 and 5.5, I would find the area under the curve between 5 and 5.5. So that area represents the probability of getting an x that's between 5 and 5.5. Now when we talked about probability discrete random variables, I said that if you added up all the probabilities, you should always get 1. Similar thing here. If you looked at the area under the entire curve, you should get 1. Now for us, the main curve that we'll be talking about is a curve that looks like this. And this is a curve that we've seen before. We saw this curve when we talked about the empirical rule. So let's do a little recap of the empirical rule. The lengths of episodes of TV shows on Netflix are normally distributed. So all that means is that the probability distribution looks like this, with a mean of 43 minutes and a standard deviation of 6 minutes. So to use the empirical rule, what we did was we put the mean in the middle. Mean here is 43. And then we use the standard deviation to go up 3 times and down 3 times. So starting with the mean, plus the standard deviation, so 43 plus 6, that's 49. Plus the standard deviation again, plus 6 again, that's 55. And then plus 6 one last time, 61. Going the other direction, subtract 43 minus the standard deviation, 43 minus 6, that's 37. Minus the standard deviation again, that's 31. And then minus the standard deviation one last time, minus 6 one last time, 25. And what the empirical rule says is between 1 up, 1 down is 68% of the data. Between 2 up, 2 down is 95% of the data. And then between 3 up, 3 down is 99.7% of the data. And then the entire picture is 100%. And using the empirical rule, we were able to answer questions like, what percent is less than 49, or what percent is below 49. And the way we found that was we broke this up into two pieces. So 49 to the middle, and then the middle all the way to the left. 49 to the middle should be half of the 68%. So half of 68% is 34%. And the middle all the way to the left, is half of the 100%. And half of 100% is 50%. And then that together, 50% plus 34% is 84%. So 84% of the data is below 49. These numbers here represent minutes, and we're talking about Netflix shows. So 84% of Netflix shows is below 49 minutes. Now, the limitation of the empirical rule is we can only answer questions for minutes that are exactly on one of these steps. What if I asked, what percent is less than 52 minutes? This is a problem. 52 minutes is not exactly on one of these steps. 52 minutes is somewhere between 49 and 55. We can't answer this using the empirical rule. So today we'll talk about how we can answer questions when we don't land exactly on one of these steps. There's three tools that we'll need today. The first tool is the standard normal distribution. So what's the difference between a standard normal distribution and a normal distribution that we talked about on the front page without the word standard? So normal distribution refers to any distribution that has this shape. And every situation we'll be talking about today will have this same shape. What will differ will be the numbers at the bottom, which have to do with the mean and the standard deviation. So standard just refers to the simplest possible situation where the mean is 0 and the standard deviation is 1. So let me fill out this picture with a mean of 0 and a standard deviation of 1. So put the mean in the middle, and then we'll use the standard deviation to go up 3 times and down 3 times. So 0 plus the standard deviation, 0 plus 1, that's 1. Plus the standard deviation again, plus 1 again, that's 2. And then plus the standard deviation one last time, that will be 3. Going the other direction, subtract 0 minus the standard deviation, so 0 minus 1, and that's negative 1. Minus the standard deviation again, so minus 1 again, negative 2. Minus the standard deviation one last time, negative 3. So that's the picture for the standard normal distribution, where the mean is 0, standard deviation 1. Now, the next thing I'll need is a way to convert from the non-standard picture to the standard picture. Okay, so I know that 43, which is the mean, is going to go with the 0. 49, which is one step above, that's going to go with the 1. 55, which is 2 steps above, that's going to go with the 2. So what I would like to know is, what we're interested in was this 52, right? What percent is below 52? I know 52 is somewhere between 1 up and 2 up. So on this picture, it should be somewhere between 1 up and 2 up. But I want to know exactly how many steps above. That's going to be the z-score. So z-score is going to tell you how many steps or how many standard deviations above or below the mean. Let me tell you what some of these symbols mean. Z is the z-score. X is the data value that you want to find how many steps above or below the mean of. So X would be this 52 that we're talking about. Minus mu, that's the symbol for the mean. On the bottom, sigma, that's the symbol for standard deviation. Okay, so let's find the z-score for this 52. Okay, that 52 is our x, minus the mean. The mean for the Netflix example was 43. On the bottom, sigma, standard deviation. The standard deviation for that Netflix example was a 6. All right, so let's enter this new calculator. Up top, 52 minus 43. On the bottom, 6. 1.5. Okay, so what we found was we said the 52 was somewhere between 1 step and 2 steps above. So 1.5, that's telling me 52 is exactly 1.5 steps above the middle, or 1.5 standard deviations above the mean. Which means on this standard normal picture, that 52 would be exactly 1.5 steps above the middle also, which is right here. Now, why did I want to convert from a non-standard picture to a standard picture? Well, we were interested in what percent is below 52. And we know 52 now goes with the 1.5. So what percent is below 52 is going to be the same as what percent is below 1.5. And I can answer the question on the standard normal picture because I have a calculator that will tell me what percent is below 1.5 on the standard normal picture. Which brings me to the calculator, which is R. So in R, we're going to be using two commands, pnorm and qnorm. Pnorm is for a situation where we want to go from Z to an area. So if I know a Z, like I do here, and I want to know what area is to the left of it, I would be using pnorm. And then there are situations where we want to go backwards, where we have an area and we want to know what Z has that area to the left of it. In that case, we'll be using qnorm. There's two main types of questions that you'll encounter, x to area and area to x. Area, we said earlier that the area under a curve is the probability. So area here is referring to probability. Other words for probability that you'll encounter are going to be percent and proportion. So if you see any of these P words, probability, percent, proportion, you should think area. And the diagrams here are telling you what to do in each situation. For an x to area question, you're going to first do x to z using this formula, which is the z-score formula, and then you're going to do z to area by doing a pnorm in R. For an area to x question, you're going to first do area to z by doing qnorm, and then you're going to go from z to x using this formula for x. Now, this formula for x is really just this z-score formula if you do algebra and get the x by itself. So if you do algebra and get the x by itself, the first thing you would do is multiply both sides by sigma, and then you'll add mu to both sides, and you'll get exactly this formula for x. So let's try some examples. Example 1. The amount of time customers spend waiting in line at a grocery store is normally distributed with a mean of 2.58 minutes and a standard deviation of 0.76 minutes. Find a probability that a randomly selected customer waits less than 4 minutes. The first thing I do on all these questions is draw the normal distribution picture and put the mean in the middle. So our mean here is 2.58 minutes. I'm also going to label what this x-axis represents. So this x-axis, which has this 2.58, what is 2.58? 2.58 is the minutes. So this is going to help me because anytime I refer to minutes, that's going to be an x because this is the x-axis. The second thing I need to decide is this an x to area question or an area to x question? So the easiest way to decide is to read the question, that very last sentence. It says, find the probability. Probability, I said, anytime you see one of those P words, you should think area. So that probability is saying area. Find the area. So I want to end with an area as my final answer. Which one of these ends with an area? X to area. Okay, so this is an X to area type question. Another way to think about it is, let's read this last sentence again. Find the probability that a randomly selected customer waits less than 4 minutes. So I'm giving you this 4 minutes. Is that 4 an area or an X? And so this is why I labeled the x-axis, right? X-axis here's minutes, which means when I talk about minutes, it's an X. So that 4 minutes is an X. So in this question, I'm starting you off with this 4 minutes. So I'm starting you with an X. Which one of these starts with an X? X to area. Okay, so we agree it's an X to area question. Let me draw the rest of the picture. So I need to put this 4 on my picture. This 4 we said was an X. That goes on the X-axis. 4 is more than 2.58, so that goes to the right here. And then I need to decide how to shade this picture. So I said there are 2 main types. Within each type, there are 3 pictures that you can encounter. Either shaded to the left, shaded to the right, or shaded in between. This one says, find a probability that a randomly selected customer waits less than 4 minutes. So less. Less would be to the left. So this is going to be shaded to the left. So this is an X to area type question that is shaded left. And now we just follow the diagram. Okay, so we say it was X to area. First thing we need to do is go from X to Z using this Z-score formula. Okay, so we'll use the Z-score formula. X we said was the 4, minus mu, that's the mean. The mean is this 2.58. And then over sigma. Sigma is standard deviation. What is the standard deviation here? Standard deviation, 0.76. All right, so do this on your calculator. Let me switch over. So on a calculator, up top, 4 minus 2.58. On the bottom, 0.76. Round to 3 decimal places. This is 1.868. Okay, so we just did this Z-score formula, so that got us from X to Z. Next step is go from Z to area, doing a p-norm. Okay, so this p-norm is going to be in R. So we're going to do p-norm and then we enter the Z. So our Z was 1.868. So 1.868. So we did p-norm 1.868 and we got 0. Rounded to 3 decimal places. This is 0.969. Now, sometimes that's our answer, and then sometimes we have to do something to it. And what you have to remember is that the way p-norm works is p-norm, you feed it a z, and it's going to spit out the left area. So this output, this 0.969, is the left area. And what you want to ask yourself is, are you looking for the left area here? Yes. So you're looking for the left area. So that's just our answer. So 0.969. Example 2. The cholesterol levels for US adults are normally distributed with a mean of 201 and a standard deviation of 46. What cholesterol level separates the lowest 22%? First thing I always do is draw the normal distribution picture and put the mean in the middle. The mean here is 201. And I also want to label what this x-axis represents. So this 201, what is this 201? This 201 is a cholesterol level. And now the next thing I want to decide is this an X to area type question, or is this an area to X question? So let's read that last sentence, the question. What cholesterol level separates lowest 22%? So I want to end with a cholesterol level. Is that an X or is that an area? Cholesterol level, that's on the X-axis, that's an X. So I want X as a final answer here. Which one ends with an X? Area to X. So this is an area to X type question. Okay, another way to think about it is in this question here, this last sentence, I'm giving you this 22%. What is the 22%? 22% is one of those P words that I said you should think area. That 22% is an area. So another way to think about this is in this last sentence, the question, I'm giving you an area to start. Which one starts with an area? Area to X. So this is an area to X type question. Now, let me fill out the rest of the picture because I need to decide whether this is shaded left, shaded right, or shaded in between. I need to put this 22% on my picture, okay? So this says the lowest 22%. So the lowest 22%, lowest would be on the left side, right? Lowest is on the left side. So this will be shaded left. That 22% is not an X, so I'm not going to put it on the X-axis. That 22% is an area. So areas, I'm going to label above the picture, so right here. And anytime we're talking about percents, we always have to convert it to a decimal. So 22% as a decimal is 0.22. And what I'm looking for is I'm looking for an X. I'm looking for this X that has a 0.22 to the left of it. Okay, that's the setup. So this we said was an area to X, and actually let me write here that we said this was shaded left. Left because it said lowest. Lowest is on the left side. This is an area to X, shaded left, area to X. First thing I need to do is area to Z by doing a Q norm. So Q norm, the left area. So first thing I'll do is I'll do a Q norm. The left area is this 0.22. Okay, so in R, we're going to do Q norm 0.22. And then round to 3 decimal places. Negative 0.772. Okay, Q norm spits out a Z. So that negative 0.772 is a Z. We just did the Q norm. Next step will be to go from Z to X by using this X formula. So that X formula says X equals mu, that's the mean. The mean in this case is 201 plus Z times sigma. So Z is this negative 0.772. What is it? 772. Sorry, this should be 772. Times sigma, which is standard deviation. So standard deviation for this question was 46. Okay, so on a calculator, we'll just do 201 plus negative 0.772 times 46. 165.488. Example 3. A survey among freshmen at a certain university revealed that the number of hours spent studying the week before final exams was normally distributed with a mean of 25 and a standard deviation of 7. What proportion of students studied more than 40 hours? First thing I always do is draw the normal distribution picture and put the mean in the middle. The mean here was 25. And then I always label what this x-axis represents. So this x-axis, which has the 25, what does the 25 represent? The 25 was the number of hours spent studying. So 25 is hours. The next thing I wanted to decide is what type of question is this? Is this an x to area or is this an area to x? Okay, so to decide, I usually look at the very last sentence, the question. What proportion? Okay, proportion is one of those P words I said that refer to area. So probability, percent, proportion, all of those are areas. So what area? So this is asking for an area as your final answer. Which one of these ends with an area? X to area. So this is an X to area type question. Another way to think about it is to look at what else am I giving you in this very last sentence. What proportion of students study more than 40 hours? 40. What is the 40? That 40 is in hours. We said the x-axis represents hours, so that 40 is an x. So that 40 is an x. So another way to think about it is I'm giving you an x to start. Which one starts with an x? X to area. So this is for sure an x to area question. Next thing we need to decide is whether this is shaded to the left, shaded to the right, or shaded in between. Okay, so this says, what proportion of students studied more? So more than would be to the right. So this is to the right. This is shaded right. 40 we said was an x. So let me put that actually on the x-axis. So x-axis 40 would go over here. So more than means to the right. So this is an x to area type question that is shaded to the right. Okay. X to area, first thing we need to do is go from x to z using the z-score formula. So z-score formula. Okay. Our x was the 40 minus the mean. The mean here is the 25. On the bottom is the standard deviation. So standard deviation in this case was 7. All right, so go to the calculator. Up top, 40 minus 25. On the bottom, 7. Rounded to 3 decimal places, this is 2.143. All right, so we just did the z-score formula to go from x to z. Next step will be go from z to area using p-norm. So we're going to p-norm that z. So p-norm to 2.143. Right, so this time in R, we're going to p-norm 2.143. Round this to 3 decimal places. This is 0.984. Okay, one thing to remember here is that p-norm, you feed it a z, it's always going to spit out the left area. So this 0.984 is a left area. Question is, am I looking for a left area? I'm not. I'm looking for a right area, right? To the right. Right. So this is actually not the answer I want, right? Because this is the left area. This is this white part, the unshaded part. So how do I get the shaded part? Well, the shaded part is the complement of the white part, right? So all I need to do is do 1 minus that. And another clue that you want to do 1 minus here is because based on my picture, that's a small area. But 0.984, that's pretty big. That's like 98.4%. So I know for sure that that's not the right answer. Okay? So 1 minus 0.984. (0.016). Example 4. Men's heights are normally distributed with a mean of 68.6 inches and standard deviation 2.8 inches. Find the height that separates the tallest 3% of men. First thing I always do, draw the normal distribution picture and put the mean in the middle. So our mean here is 68.6. And then I'm also going to label what this x-axis represents. So this x-axis, 68.6. What is this 68.6? This 68.6 is inches, or height. So anytime I see inches, that's an x. So next thing I need to decide is this an x to area or an area to x? Okay, so let's read that last sentence, the question. Find the height, okay, height. Is the height an x or is that an area? Inches, which is height, is the x, so that height is an x. So this is saying find the x. So I want x as my final answer. Which one ends with an x? X to area or area to x? Area to x. So this is going to be an area to x question. And then the other way to think about it is to look at what else am I giving you in this question. I'm giving you this 3%. All right, percent, one of those P words that stands for area. So I'm giving you an area to start. So start with area. So this is area to x. Okay, so now let me draw the rest of the picture. So I need to actually draw whether it's shaded left, shaded right, or shaded in between. Tallest. Tallest, same thing as highest, biggest. Biggest will be on the right side. So this is going to be on the right side. That 3% is an area, so I'm not going to put that on the x-axis because x-axis are heights. That 3% is an area that goes up here. 3% converted to a decimal would be 0.03. So be careful, it's not 0.3, it's 0.03. So 2 to the left, 0.03. All right, so that's the setup. This is an area to x that's shaded to the right. Okay, let's look at my diagram to see what I should do next. Area to x, first thing I need to do is go from area to z by doing q norm left area. So q norm left area. Okay, left area. 0.03 is the area to the right. I need to q norm the left area, which is this white part. So if 0.03 is this shaded part, what's the white part? And how would you get the white part? So anytime you want the other side, do a 1 minus. Okay? So 0.03 is to the right. The left part will be 1 minus 0.03. So 1 minus 0.03 is 0.97. So 0.03 is the shaded part to the right. The white part to the left is 0.97. Q norm always takes the left part. So we're going to Q norm 0.97, right, and not 0.03. So Q norm in R, 0.97, 1.881. Okay, that's a Z because Q norm takes an area and it spits out a Z. So that's a Z, 1.881. All right, so we just did the Q norm. That got us to Z. Now we go from z to x by doing this x formula. So x equals, okay, formula says mu, the mean, what's the mean? 68.6 plus z, our z is this 1.881, times the standard deviation, 2.8. Right, so on a calculator, 68.6 plus 1.881 times 2.8. Round to 3 decimal places, this is 73.867. Notice that in the two examples that we just did, example 4 and example 3, both of those pictures were shaded to the right. Shaded to the right, shaded to the right. Anytime your picture is shaded to the right, you will have to do a 1 minus at some point in the process. And you're going to do the 1 minus on the area. If it's an x to area question, the area is at the end. So you're going to do a 1 minus at the very end right before you get the final answer, which is what we did there. 1 minus at the very end to get the final answer. For an area to x question, the area is at the beginning. So you're going to do the 1 minus at the very beginning right before you plug it into Q norm, which is what we did there also. We did a 1 minus to get to 0.97, and then we plugged the 0.97 into the first step Q norm. So once again, anytime your picture is shaded to the right, you will have to do a 1 minus, and you're going to do the 1 minus on the area. So if it's an x to area is at the end, do the 1 minus at the end. For an area to x, area is at the beginning, do a 1 minus at the beginning right before you plug it into Q norm. Example 5. A soda machine dispenses soda into 12-ounce cups. Tests show that the actual amount of soda dispensed is normally distributed with mean 11.5 ounces and standard deviation 0.21 ounces. What percent of cups will receive between 11.2 ounces and 11.45 ounces? First thing I always do is draw the normal distribution picture and put the mean in the middle. Our mean here is 11.5. And then I always label what the x-axis represents. So this 11.5 on the x-axis here was ounces. So anytime I see ounces, I know that's an x. Next thing we need to decide is whether this is an x to area or an area to x. X to area to x. And the way I usually figure that out is read the question. So what percent? So percent is one of those P words that I said refer to area. So this is asking what area. So I want area as the final answer here. So which one ends with an area? X to area. So this one has to be an x to area. And then another way to think about it is look at what else I'm giving you in that question. I'm giving you this 11.2 ounces and this 11.45 ounces. Ounces, we said, was on the x-axis, so both of those are x's. So I'm giving you these x's to start with. So which one starts with an x? X to area. Next thing I need to decide is whether this is shaded to the left, shaded to the right, or shaded in between. So let me put these x's on here. So we said 11.2 and 11.45 were x's. So both of those will go on the x-axis. And both of those are actually both less than 11.5. So let me put them on the left side. It says here between. So I'm looking for the area between 11.2 and 11.45. So I'm looking for that area. Okay, so we're set up now. This is an x to area that is shaded between. Okay, x to area, first thing we should do is the z-score. Okay, I have two x's here, so I need to do two z-scores for both of them. So let me start with the 11.2. So it's going to be 11.2 minus the mean The mean is the 11.5 over the standard deviation, 0.21. Let me set up the other one, and then we'll just do the calculator for both of them at once. So the other one is, the other x was the 11.45 minus the mean was 11.5 over the standard deviation, 0.21. Okay, so let's calculate both of those. Okay, so the left one, 11.2 minus 11.5 on top over 0.21. Round to 3 decimal places, this is negative 1.429. Okay, the z-score for the other x, up top 11.45 minus 11.5 over 0.21. That is negative 0.238. Okay, so we just did the first step, which is the z-score for both of the x's. Next step would be z to area by doing a p-norm. So we're going to p-norm both of those z's. So p-norm negative 1.429, and then also p-norm negative 0.238. All right, so in R, p-norm negative 1.429, 0.077. Okay, the other one, p-norm negative 0.238, 0.406. Okay, remember the way p-norm works is you feed it a z and it spits out left area. So both of these are left areas. Okay, so 0.077 is the area to the left of this 11.2. 0.406 is the area to the left of this 11.45. We want the area between. Okay, so how do we find the area between? Take the area to the left of this 11.45, subtract the area to the left of 11.2. So take the two left areas and subtract, and that will get you the area between. Take the bigger one first, so 0.406 minus 0.077. Okay, so on the calculator, 0.406 minus 0.077, 0.329. Okay, so anytime you're looking for the area between, find the two left areas from p-norm, subtract them, and that will get you the area between. Example 6. Laptop batteries have a mean battery life of approximately 11.5 hours with standard deviation 4.37 hours. Between what two lifetimes do 81% of batteries fall between? First thing I always do, draw the normal distribution picture, put the mean in the middle. Our mean here is 11.5. And then I always label the x-axis for what this 11.5 means. So this 11.5 is 11.5 hours. Okay, so anytime I see hours, I know it's going to be an x. Okay, hours here is the battery life. Next thing we need to decide is whether this is x to area or area to x. X to area to x. Okay, so read the question. Between what two battery lifetimes? So I want to find two battery lifetimes. So I'm looking for two battery lifetimes at the end of the question. Battery lifetimes, those are the hours, right? So I'm looking for two x's as my final answer. Okay, so I want to end with x's. So this would have to be an area to x question. Okay, another way to think about it is, what am I giving you in this last question? I'm giving you this 81%, right? Percent, one of those P words that stands for area. I'm giving you an area to start. So it has a start with area, so area to x. Okay, let's draw the rest of the picture. Is it shaded left, shaded right, or shaded between? I see the word between. This will be shaded between. Okay, so this is shaded between. Shaded between. This 81%, that's an area, so that doesn't go on the x-axis, that goes up here. So 81% as a decimal, that's 0.81. Okay, I'm looking for two x's that have an area of 0.81 between them. So two x's that have 0.81 between them. Okay, so that's a setup. This is an area to x, shaded between. Okay, so for an area to x, our first step, area to x, first step, Q norm, the left area. Okay, first step is to Q norm the left area. What goes inside? Q norm the left area. So we have to Q norm and plug in the left area of the picture. Left area of the picture is not 0.81. 0.81 is this area in the middle. Left area is, I'm talking about this white one to the left here. So I have to find that area to plug into Q norm. How do you find that left area? 0.81 is the shaded part. Actually, let me use green here. 0.81 is the shaded part. Let me first find the white parts. So 0.81 is the shaded part. To find the white parts, do 1 minus. Okay, so 1 minus 0.81. What's 1 minus 0.81? 0.19. Okay, 1 minus 0.81 gives me the white part, which is 0.19. That's both of them. I just want the left one. What do? Divided by 2. Okay, so take the 0.19 divided by 2. So 0.19 over 2, 0.095. Okay, that's just this left white part. Okay, which is what I want to plug into Q norm. So Q norm, you're always going to plug in the left area of your picture. So the left area, this left white one, is 0.095. Okay, once again, the way we got it is 1 minus 0.81. That gave us the white part. And then because I only wanted the left one, divided by 2. So 1 minus and then divide by 2. Right, so Q norm in R. Q norm 0.095. Negative 1. Okay, so Q norm, remember Q norm goes from area to a Z, so that was a Z. Negative 1.311. Now remember, I want two x's at the end of the day, right? So I need actually two z's. That's one of them. So negative 1.311 goes with this left x. What do you think the right one is? Because I need another z. The right one's going to be positive. So positive 1.311. Okay, so those are my two z's. Now last step, go from z to x by using this x formula. So we'll use the x formula for both of the z's. The first one's going to be x equals. So formula says mu, the mean here is 11.5, plus z times the standard deviation. So plus negative 1.311 times the standard deviation, 4.37. Okay, so let me do that one right here. 11.5 plus negative 1.311 times 4.37. 5.771. So round to 3 decimal places. 0.771. Okay, so that's one of the answers. Do the x formula for the other z. That's x equals the mean, which is 11.5, plus z times standard deviation. This time the z is 1.311. Standard deviation 4.37. Okay, calculator 11.5 plus this time positive 1.311 times 4.37. 17.229. Example 7. Scores on a statistics final in a large class were normally distributed with a mean of 75 and standard deviation 8. Find the 85th percentile of exam scores. As always, first thing I do is draw the normal distribution picture and put the mean in the middle. Our mean here is 75. And then also label that x-axis. So what does the 75 mean? The 75 was scores on the statistics final. So 75 is the score. Now the question is this an x to area or is this an area to x type question? And this one's a little tricky because you have to remember what 85th percentile means. So we talked about percentile back in unit 1. So 85th percentile means 85% of the data is below. Right? Percentile means percent that's below. So right off the bat, I'm giving you a percent. Right? I'm giving you an area. So this would have to be a area to x, right? Because you're starting with an area. So basically, you're looking for the exam score that has 85% of the data below it. So you're looking for an x that has 85% of the data below it. Below will be to the left. So this is going to be shaded to the left. Okay, so I'm going to draw this shaded to the left. Now, I know that the x would have to be on the right side. Now, it's not that important that you have the x on the right side. I'll talk a little bit more about why I know it's on the right side in a little bit. So this 85%, right, that is an area. So that doesn't go on the x-axis. Areas go on top here. 85% as a decimal is 0.85. So we're looking for the x that has an area of 0.85 to the left of it. Now, why do I know that the x is on the right side here? Well, I know that that's 50%, right? If the x is on the left side, then I have that area to the left, which is less than 50%. So because I want an area of 85%, it would have to be over here, right? To get an area that's big enough to be 85%. So once again, it's not that important that you have the x on the right side. What is important is that you have your picture shaded to the left. Okay, so this is a area to x. First thing I need to do is do a Q norm left area. Okay, the left area of this picture, so left area is the shaded part. The area of this shaded part is 0.85. Okay, so that's already the left area, so I don't have to do anything to it. All right, so let's go to R. Q norm 0.85. Okay, 1.036. So Q norm gets you from area to Z, so that's a Z. So Z here is 1.036. Okay, so we already did area to z, q norm. Last step is go from z to x by doing the x formula. So x formula, x equals mu, the mean. Mean here is 75. Plus z times the standard deviation. So z here is this 1.036 times the standard deviation, 8. Okay, plug this into a calculator. 75 plus 1.036 times 8. 83.288. All right, that's it for today. Have a great day. See you next time.